So this is our last class, or it's our final 8th class, and my first question for you guys is, how did you feel about what you learned in the past 7 classes so far?
I learned a lot.
How about you, Shani?
Um, so yeah, I've learned a little.
Yeah, I know you couldn't attend the first few, but did you learn a little bit in the last few lectures?
Yeah.
Okay, that's nice. Yeah, so yeah, so here we're gonna start with something a little bit fun today. So we're gonna do some like fun with the math here. So we're gonna do some special cases. Like, look, like let's say I gave you, I don't know, 25 times 25. How would you do that? Just somebody raise your hand and tell me, how would you solve this problem? Yeah, Janak?
What I would do is I would use base 20, so you do 10 times 2 for your base of 20.
And then?
And then you would do, you'd extend the line, and then you do, sorry, I can't think right now, my mind isn't working.
What goes on
You
this
do,
side?
huh?
What goes on this side, on the right side?
Oh, yeah, you would do, minus 5.
Would it be minus
Plus 5, sorry.
5?
Because 20 plus 5 would be 25.
Yes.
And then you do the same thing down below. And then you'd have the line just to separate the two. And then you do 5 times 5 is 25. So on one side of the line, you'd have 25. And then 25 plus 5 is 30. So you'd put 30 on the other side. But you can only have, then you'd multiply 30 by 2.
Why would you multiply 30 by 2?
Because your base is 20 and you multiplied your original base by 2.
Good job.
And then since you can only have like one digit because there's 1 0 at the end, you'd carry the 2 over and make it 625.
Good job. So notice how we did all that and we got 625. Now, 25 times 25 is a special case. It's a special case of multiplication where there's a simpler method that you could use. So here's the method that I would use when I see 25 times 25. 25 times 25. Well, I notice that 5 plus 5 is 10, and I notice that the rest of these digits are the same. So what I would do is I would write 2 times 3 equals 6, and then after that, all I have is 25. Now let me sort of explain to you how this works again. So yeah, I'm going to erase this real quickly, and I'll do a different example. This time, let's say 13 and 17. Right. So what you do is you notice that the last digit, for the first step is looking at just the last digit. You see how they add up to 10? So the fact that they add up to 10 means we can use this method alongside the fact that these two are the same, right? So you have the last digits add up to 10, and if you take away the last digit, the rest of the numbers are the same. So what you do is you take the first digit and you multiply it by 1 more than itself. So you take this 1 and you multiply it by 2. And then you take this 3 times 7. That's 21. And you just stick it down here, 21. And that's your answer, 221. You see how easy that is? Now I want you guys to try 48 times 42. Ishani, did you get it yet?
Could you re-explain how you got the 2 in the beginning?
Okay, so this first 2 came because 1 times 1 plus 1 is equal to 2. So I have to take the first digit and I have to add 1 to it, and then I multiply it by the first digit again. Let me know when you get it.
To be honest, I know it's an easy method, but I still don't really understand it.
Okay, that's fine. So the first step is noticing that this 8 and this 2, they add up to 10. And then you see when you take away the 8 and the 2, the digits are the same. The rest of the number is the same. You got 4 and 4 here. So what you do is you take this 4 and you multiply it by 5, by 1 greater than it. So what's 4 times 5?
20.
20. Now what's 8 times 2?
16.
So what you do is you just write this over here. And that's your answer, 2016. Okay, do you understand now?
Yeah, kind of.
Okay, so here's what we're going to do. We are going to do this with a slightly harder number. We're going to do 124 by 126. Now you can try this. And you can just raise your hand when you've got it. Are you having trouble, Ishani?
I'm still trying to figure it out.
Okay, here, let me explain this. Okay, so the first step is noticing that the last digits add up to 10. 4 plus 6 is 10, right? And now when you take away the 4 and the 6, when you remove them, you notice that the numbers are the same. You have 12 and 12 here. So now you do the method the same way that you did before. You take 12 and you multiply it by one more. You multiply it by 13. Now what's 12 times 13? It's 156. And now what's 4 times 6? Well, that's 24. And you just stick it to the end, 24. Do you see?
Yeah.
Yeah. Now, this method can actually be used for more than just one digit. Now, let's say I had 250, nope, that's bad. 207, let's say 98 multiplied by 202. Now, what you can notice is that the last two digits do add up to 10, but if you take them away, the rest of the number is not the same. But what you can notice is that the last two digits add up to 10. You notice that? Or they don't add up to 10, they add up to 100, my bad. So 98 plus 2 adds up to 100. Now, if we didn't use this fact, that would be a real shame. So how we're going to approach this is just as we did before. But this time, we're going to write 2 times 3. So we're going to increase this by 1 and add it to and multiply it, right? So 2 times 3 is going to be 6. And on the right-hand side, we're going to have 98 times 02. Can any of you guys quickly figure out what 98 times 2 is?
$148.
98?
Sorry, 240.
Nope. 98 times 2.
196?
Nice job, Ishani. 196. All right. So our answer, our right-hand side is going to have 196. But because there's a 0 here, because there's 2 digits each, we're really going to want 4 digits on the right-hand side. So what we're really going to want is 0196. So 298 times 202 is going to give us 60,196. Yep, and we can let me put it in a calculator to just check that real quick. 8 times 2. Yeah, I'm just making sure. Yeah, so 298 times 202 is equal to 60,196. Okay, so can you guys kind of understand why this happens? Does any of you have a guess?
I'm sorry, could you repeat the question? I had to mute my computer for a little bit.
You're good. Do any of you know why this happens, or do any of you have a guess?
Maybe it's because of the 0 before the 2.
No. Not why we can use this method. Why we could say that 14 times 16 is equal to 224, just like that.
Because 4 times 6 would be 24, so you'd have the 24 on the side as well. But like, but since it also equals 10, you'd add the 1 to the other one, and then you do 2 times 1, which would be 2. So you'd have the 2 in the left.
So yeah, that is basically true, right? So let's do it this way. Let's do a little bit of algebra. I'm going to teach you guys algebra. Do you guys are you guys familiar with algebra at all? Okay.
Very basic algebra.
So here's what I'm going to do. I'm going to write 4 numbers, A, B, and A, C. So A is going to be the tens place, and B is going to be the ones place. This is not multiplication. Okay? So A is going to be the tens place, B is going to be the ones place, and C is also going to be in the ones place, right? And so we're going to have that B plus C equals 10. That's all we need, okay? So now this is going to be a base, right? And so we can write this base as like we can write this base as A0 equals 10 times A. Because if you put this here and you have the zeros placed here, that's the same thing as multiplying by 10, right? Because multiplying by 10 is adding a 0 on the end. Okay, do you guys understand this? Now, I'm going to write a plus B and a plus C here, because this one is B more than this is A0, and this one is C more than this A0. Yeah? Okay, so now we're going to do this the same way we did it before. What is B times C? That's just going to write B times C. And now we're going to add these, AB plus C. Now I want to look at this number, AB plus C. What is this AB plus C? What does AB equal to? Can somebody I just need one addition formula for AB.
A0 plus B.
Yeah, and what does A0 equal to?
10 times A.
So we're going to write this as 10 times A times, not times, 10 times A times 10 times A plus B, and then plus C, right? But what is B plus C?
10.
B plus C is just 10. So this is going to equal 10 times A plus 10. Now, can one of you tell me what this is going to equal to?
I want to say 11 times A, but
Nope, it's not 11 times A. Remember, this is algebra. So, okay, so let's think of it this way. So right now we have an A number of tens, right? And A is a digit between 1 and 9, or 1 and it could be 0 as well, but 0 is boring. But so we have a number of tens that is a digit A, right? And if you add one more, how many tens do you have?
A plus 1.
A plus 1, that's exactly correct. You have A plus 1 tens. And now, so what does that mean for this formula? What is this formula going to equal?
Ten times A plus 1.
10 times A plus 1. So on the left-hand side, we're going to have 10 times A plus 1. And on the right-hand side, we're going to have B times C. Now this could be a problem, but we are saved by one thing. We are saved by the fact that the left-hand side is a multiple of 10, right? So let's give an example, right? Like, what if B is 4 and C is 6? Then B times C is going to be
24.
24. If B times C is 24, but our base over here is 10. Well, that's an issue, isn't it? Yeah. So we're saved by one thing as well. And remember, on the left-hand side, there's another step that we have to have, actually. We have to multiply by A. Do you guys remember why we have this step? So now this is going to equal, so we're going to multiply by a, and we're going to get 10 times a plus 1 slash b times c. Now, here's what we're saved by. So we know that the right-hand side is only going to have one digit, and so the other digit is going to carry, because the highest number you can have for the right-hand side is going to be 25. You can't have a number greater than that for the right-hand side. So we're going to have one digit carry, right? But that could mess up with our calculation. But we're saved by the fact that the left-hand side is multiplied by 10. So there's actually going to be a 0 in that position, right? So if there's going to be a 0, and if the other digit is carried over, then that allows us to say that, hey, what if we allow this to carry, but that spot just fills a 0? So now you're left with the left-hand side being just a times a plus 1, and the right-hand side being b times c, and you don't need to carry. Do you guys see this formula? So now, let's say we do it with something like, let's say we do a practical example of this, right? So let's say we have 73 times 77. Now, what is a equal to? Somebody just raise your hand and tell me. Ishani?
7.
A is equal to 7. Nice job. Now, what is b equal to?
3.
And c?
7.
7. Good job. So, oops, that was better at 7. A, B, and C are both equal to 7. No, A and C are both equal to 7, and B is equal to 3. So now, I'm going to have somebody use this formula to solve this problem, right? So the left-hand side is good. The left-hand side is going to be a times a plus 1. What is a times a plus 1 going to be? 7 times
8.
8. And the right-hand side is going to be b times c. What is b times c?
21.
Well, it's equal to 3 times 7. And what is 7 times 8? That's 56. And 3 times 7 is 21. So this is our final answer. So do you guys understand why this works? Now you guys have an algebraic understanding of why it works. And you also, sort of, and you also have a lot of practical examples, which I think is important for this scenario. So yeah, that's kind of a quick way to do multiplication when you notice these things, right? So think of it like this. Do you guys remember the past example of 124 times 126? How did you solve that one? Just let me know.
Now, what I did was, let me find it on my paper. Give me 1 second. So since 4 plus 6 is 10, and they both have 12s, I guess you could say 12 in the tens place, because then that would mean 120.
Yeah.
But it's still the same number. So I added to one of the 12s to make it 13, and I did 13 times 12 to get 156. And then 4 times 6 is 24, so I got 15,624
Is that what you did right now, or is that what you did last time?
last time.
Last time. Okay, good catching. So yeah, that is the easier way actually to do it. But most people would probably have done like, say, base 100, right? And then you have 124 times 126, and what they say is this is 24 greater and this is 26 greater, and then they do a big multiplication, which is going to end up being 624, and that's going to be another multiplication they have to do, and they have to add this here, 130, and then they got to bring it over 150. And they got to bring it over, right? Because this is 100. Only 2 digits are allowed. So 15624. That's probably what most people did, which has lots and lots of steps. But see the way that you did it, it was kind of like a shortcut way to get from that older method to this quick and easy and fun method. So here I'll give you guys another problem to see if you can figure this out on your own. And yeah, so here, let's say 1, 3, 2, 7 times 1, 3, 7, 3. Nah. Okay. So what did you end up getting?
1,821,971.
Same.
Good job. So you both noticed the same thing, and you yeah. So yeah. That's a very good job. All right, now here, let me show you something cool. What is 1 divided by 19?
1/19.
Can you give me a decimal form of it? How quick can you do it?
It would take me time.
It would take you time. Let me write it out really quick. second, I wrote the wrong thing here. Yeah, my bad. So my final answer is going to be 0.05 2631578947368 I should write it better. Let me write it better. 947368421, and that's going to be repeating. So I'm going to write this line. This line just means that it's repeating. I know the line was used to mean negative in other contexts, but in this, I can't write a straight line. In this context, it means repeating. Now, I'm sure you guys are curious as to how I got this, but let me tell you something else. The method for figuring out, say, 1/29 is actually very, very similar. And let me do that really quickly. It's gonna take a lot longer, but I'll explain to you how I did it and what each number means after I finish. So let's start from here, right? So 1, 3, 3. Base 4. Okay. 0.034448275862068965517241373 724137931, and it's all repeating. Now, question may be, where did I pull these numbers from? How did I get it? So let me show you the method of operation for 19, and then how you calculate the one for 20. So this is actually really cool. So here's what we do. For 19, and you may notice a pattern. The pattern being that you have to have a digit, the last digit being 9. So what you have to do is you have to say, okay, so we're going to start from the right-hand side. We're going to start from the right and we're going to go towards the left. And what we're going to do is we're going to multiply by 2. So we start with 1. What is 1 times 2? You guys can have yourselves unmuted and just say it. What is 1 times 2?
2.
2. Now, what is 2 times 2?
4.
4.
What is 4 times 2?
8.
8. What is 8 times 2?
16.
16. Now, that's a problem. I don't want to write 16. That's not really proper. So here's what I'm going to do. I'm going to write a 6 here, and I'm going to carry the 1. Now, what is 6 times 2?
12.
32.
12.
I'm sorry, 6 times 2, 12, yeah.
6 times 2 is 12. But we still have this 1 over here. We're going to carry the 1 and add it to the 12, and we're going to get 13. So our answer is going to be 13 because it's 6 times 2 plus 1. We're going to 3 and carry the 1 again. Now we're going to do it again. We have, what's 3 times 2?
6.
What is 6 plus 1? This one that's carried?
7.
7. All right. Now, what is 7 times 2?
14.
14.
And you're going to carry the 1. So what is 4 times 2?
8.
And what word are you going to write down?
9.
Nice. So what's the next thing we're going to write down?
8, and then we're gonna go
Yeah, like
Next thing? What's the next thing we write?
7.
7, but
Then you also have to carry the 1.
carry the 1. What's the next thing we write?
5, carrying the 1.
5, carrying the 1. Now what's the next thing we write?
11. 1 carrying the 1.
1
as
carry the
well.
1. 1 times 2 is 2. 2 plus 1 is 3. 3. 3 times 2 is 6. Well, there's no carrying this time. 6 times 2 is 12, and you carry the 1 here. Now
yeah.
2 times 2 is 4. 4 plus 1 is 5. Now 5 times 2 is 10. So we're going to have a 0. And we're going to have a 1 carried. Now what does this mean for the next digit?
It's going to be 1.
It's going to be 1. That's exactly where we started. We started at 1. So what does that mean?
That's where it ends.
That now it's going to start repeating. We're going to get the same pattern. If you start at 1 and you end at 1, but you're doing the same thing,
Yeah,
you're
like
going to start over and over again, right?
You start at 1, then go from right to left.
So from here, so we're going to ignore this last one. We're going to put it on the side and we're going to say, okay, we don't really need you. So what we're going to do is we're going to write our decimal point here. We're going to say, okay, here's our decimal point. That's where we start. That's our decimal. That's how we got the numbers.
Oh.
And it repeats over and over again. So the next number is going to be 0.052 ... Yep, you guys understand it?
Yeah.
All right. So as our final exercise as a class, what we are going to do is we are going to calculate 1 over 39. Now, what do you think we have to multiply by when we are doing this? For 19, we have to multiply by 2. For 20, for 29, we have to multiply by 3. So for 39, we're going to multiply by
4.
Precisely. So I'm just going to need you to tell me what the next digit is.
4.
Good.
6 carry the 1.
Precisely. 6 carry the 1.
5 carrying 2.
Good.
1 2 carry the 2.
Excuse me?
And
I couldn't
2
hear you.
carrying 2.
2 carrying 2. Good job.
yeah, that's what
Next.
it was.
0 carrying 1. 0 carrying 1.
Good. Next.
No, I mean, just
1.
Wait a second. Give me a second.
because 4 times 0 plus 1 is 1.
Yeah.
That doesn't look right. Wait a second. 2 times 4 is 8. Okay. Give me 1 second. I feel like that doesn't make any sense. Do you think that makes sense? I don't think 1 over 39. You know what? You're actually correct. Yeah. There's a reason for that. So yeah, this is actually it. Yeah. So this one actually turned out to be a lot smaller than I thought it'd be. And there's a reason. Can any of you guess the reason why this is actually like really small?
Is it because the number is increasing because the denominator is bigger?
Nope. There's another reason. And it has to do with prime numbers actually. Does that help?
Because 39 is not prime.
So yeah, 19 is equal to, there's no numbers that multiply 2 numbers when you get the 19. But 39 is equal to 3 times 13. Yeah?
Yeah.
Yeah. So that is a fact that I missed. But what that means for us is now this number actually becomes a lot smaller than you think it is. This is 1 over 39.
So it's still repeating, or
It is still a repeating number, but it is just a lot smaller than the ones before because 1 over 19 or 19 and 29 did not have like common numbers or common numbers in their denominator or in their common factors that weren't prime. All the factors of 1 and 29 or 19 and 29 were prime numbers, but the only factors were 1 and 19, right? 19 is not divisible by anything else, neither is 29. But 39 is divisible by 3 and it's divisible by 13. So that actually changes the way that these decimals look. Yeah. Okay. So I think that could be an end to this class. So this was our last problem. It turned out to be an easy one. Our last problem as a Hindi class. So I'm gonna just ask a couple questions, I guess. So my first question would be, how did you feel about the teaching style that I employed? Are there things that I could do to improve myself in the future? Or what are things you found that were helpful?
I think it worked well.
Yeah, same.
So are there things you wish that I did that in classes that I didn't do?
No.
Okay. Are there topics that you wish that I covered that I didn't cover? Okay. And so how did you feel about these past 8 classes? How did you feel that you learned about math? How do you feel about what you learned?
I feel like I learned a lot, and I feel good because this can now help further as I go up in math levels in school. It can help me instead of wasting time on doing division or multiplication, I could just do it quick and move on with my work.
Yeah, same.
Yeah, so that is something that I found really helpful, especially when I was in like middle school, right? Because I'd be able to do a lot of calculations and a lot of math a lot easier than a lot of other people. And I felt like I had a better understanding of the math. Like, do you feel like you have a better understanding of like some of the numbers and maybe like doing addition about base 10 or multiplication and division around base 10? Yeah, so that really was one of the goals. Okay, so yeah, thank you a lot. And if you guys have any questions about math ever, you can always just message me. If you have any questions about this or any other math questions, you know, I'm always a source in from the Seek in Mandal. And yeah, I don't want you guys to ever feel that, you know, you don't have anybody who can help you with your problem, because there's a lot of people that can obviously help you with the math. And if you ever, you know, have any more, if you want to know more topics, I can arrange more like one-on-one meetings, and you can like learn about other things as well if you want me to do that. Okay, so thank you, and I will see you guys. Goodbye.
Bye. Thank you.
Have a good one.